How to solve this problem? Lead code number 785 is graph bipartite using DFS. Okay, uh, the same concept. I'll start from here and I'll check. I'll go here. I'll paint. I'll color it 0. I'll color it 1. And I'll color 0. And I'll color 1. And I'll color 0. And I'll try to color 1 here. But it is already 0. That's how I'll come to know that this graph is not bipartite. So when we're given an adjacency list graph, I'll initialize my color array and for n, just fill them with -1. So for it, s0 I less than I plus plus, if color of I equal to -1, that means it is not color. So we can have multiple components also. We need to handle it. That's why I'm writing this. If my DFS give me false, then I'll return false. Of checking for all the components, and if I didn't got any false, that means if every component is by bucket, I can return. See how can we write this DFS function? What I need, I know my current. What is the color I can have? I'll paint it with 0 and the color, the graph, and number of nodes. Okay. Right. So init node, current node color, color array, and graph, number of nodes. Okay. So I'll paint the color of node with its current node color. So I'll check its neighbors. The neighbor graph of I'll check its neighbors to see when it's are colored or wrong. Color of neighbor equal to -1. If it is -1, no issues. I can color it with opposite color. What I'll do is I'll do DFS of for neighbor node. The new color should be 1 minus current node color. Current node is 1, 1 minus 1, 0 will be sent. If this current node is color is 0, 1 minus 0, 1 will be sent. It will be printed with 1. And color array, graph, n. If it is -1, we are painting its color as required. What if it is already colored and it is equal to color of my current node? That means two adjacent nodes are colored the same color. Color of node and color of neighbor are of same color, then so the condition is violated. Then I can return false. So one more thing, if it is this DFS is returning false at any point of time, then you can return false further. No need of checking. And at the end I return true. Let's see. So I got another. So this should be DFS. Sorry. Was expected I got false. Was expected I still got false. Okay, let's check for this. Here told is expected, but I got false. So I'll go with 0. Actually, color of 0 is -1. So color of 0 will be 0. And I'll check its neighbors, which is 1 and 3. I'll check for 1. 1, 0. Color array, everything will be sent. The color of 1 will be 0. And So color of 1 will be it's 1, and I'll check one address which is 0, and 0 is already colored and it is of opposite color, so no issues. I'll change 142, and over that I'll try to print my color array here. Yes. It should be 0 1 0 1. Okay, everything first, then there. So it is not coming here. So let's print this at every point of time, after every node. So 0 is painted 0, expected 1 is painted 1, and this is painted 1. So everything is done. So at the end I am returning true. So how come when wrong it is painted as required? Okay, if it is, I should keep not here, my bad. So now this will work. Okay. Let's submit this. Code accepted. That's another time and space. Complexity time. This is big of n, and this is another big of n. Where we DFSing under the graph, so every edge will be checked twice. If there's an edge between A to B, the edge will be checked when we are at node A and when we are at node B. So to do number of edges, and space color array, and recursive stack space for DFS at max the number of nodes can occupy. So this is the time and space complexity. Thank you.